Maybe we'll see. I still think we'll cover interesting content. So thanks everyone for joining. So this is my good friend Cab. Cab has been, I think a gamer for most of his life. Got into PC gaming because his parents would never buy him a console, so I had to learn stuff out of
And when we
necessity.
were kids, I would sneak over to Mark's house to play PS2 at the time. And Mark has been my gaming mentor for the past 20 years at least.
I don't know about that, but we'll see. So today, like what I'm thinking we'll cover is, so Cab and I have been sort of floating this idea around of working on a small game together. Whereas like like I know a lot about Unity, but I wouldn't call myself like an expert at it yet. But I'm much more of an expert in Unity ML agents, which is a service where you can basically add intelligence to your agents and make them do interesting stuff. So what we'll be doing kind of today is we'll be going over a lot of the public examples for how this works. We'll just be going over the code, like what it does, like how to configure it, how everything is set up in Unity, and hopefully this should be a good starting point for actually like making a game in a future episode. So Cap, the first thing I need you to do is download. So I believe you've already downloaded Unity, right?
Yeah, and I built my first game,
Okay,
which was the shooter game, and I turned gravity off to make it more fun.
okay,
So I'm
excellent.
basically an expert now.
But like you see, like that's kind of what's cool about this stuff is that you just change like a config, and all of a sudden you end up with like a game with a very different feeling. So a lot of it is just like I think tweaking buttons. But anyway, like I'm assuming, do you have Git installed on your computer?
Yes.
Okay, so I want you to Git install ML agents. So this is the URL.
One sec, one sec. I guess for the viewers, I'm not a developer. I'm self-taught. So
But I think that's
I'm
part
I'm
that's
going to
part of
have to
what
be
makes
very
this
patient.
interesting. I think
All
that's
right,
part of what
excellent.
makes this interesting.
So
So it's okay.
here's what I'm going to do. I'm going to share my screen so that actually no, you keep sharing your screen. What am I doing? Git install what?
Unity ML agents. All right.
Okay, isn't
So Hoda says hi. Yeah, I put it in the chat cap.
hi Huda. All right, nothing's in the chat yet.
Oh, sorry, in the Twitch chat. Hey, let me put it in on Hangout. Sorry. Okay, here. That. Okay, here we are. Yeah.
So when you say git install, is that just follow the documentation or do a git clone?
So you basically just git clone and then put the URL that I gave you.
Yeah,
Just put it in a folder that you'll remember.
yeah, sure, sure. Okay. Let's see. All
All
right,
right.
done.
Okay, excellent. So it should be slowly loading, right? It's a pretty big file.
Yeah, yeah.
Okay, so while it does this, like, just take a look at my screen. Like, I just want to explain at a high level, like, what the hell's going on at this point. Like, what are we really doing? And I'll just say, like, some helpful context for the rest of the talk. So usually, like, anytime, like, you make a game, like, let's say, like, what does Unity provide? And basically, like, I would say, like, Unity, even though it's a game software, I would argue that it's actually a lot more than that. So specifically, like Unity has a way for you to define like 2D to 3D models. It has animation software. It has a way to add scripts to your models. So this is what like we'll be doing this in C sharp. Um, and like you could think of all sorts of stuff. Like when I say 2D and 3D models, like this includes stuff like fluids. It includes stuff like sand animation, like rigid body versus soft body. So soft body is like you can think of it like you're simulating something like Jello, like that would be soft body or like a piece of cloth. Whereas like a rigid body is like let's say a bone, for example. So
What
that
percent of What percent of Steam games are made in Unity
Uh,
these
so,
days?
so I would say like most of them at this point. Like I don't remember the exact number, but in general, Unity is by far the most popular game engine out today for indie games, and it's followed like in AAA games. This is not necessarily as true. Like in AAA games, I would still say Unreal dominates. Uh, because it's harder to use, but at the same time, they're better at sort of real time rendering. Like if you want something to look photorealistic. But then other big studios like Valve will have their own engine, so like Source and stuff. Actually, like one interesting thing about this stuff, like game development was harder back in our day, like when we were growing up. Let's say Counter Strike. Counter Strike was a mod from the Source engine for Half Life, and so people like or like let's say Dota. Dota was a mod off of like the StarCraft level builders. Whereas now, like it's a lot easier to just make a game from scratch. Before you had to just mod existing big games, and that's how most interesting games got made. So specifically, like so there's 2D models like animation software, adding scripts. There's like movie making software. What I mean by that is that like you can basically program a camera to move around in a scene. And so you can just straight up make like a Pixar-like animation with the same kind of software. But the main thing we're going to be looking at today is AI, like specifically reinforcement learning software.
Perfect.
But as part of that, we're going to be working with a 3D model. We're going to figure out how to animate it, and then we're going to figure out how to program its behavior using reinforcement learning. So,
Great.
so let's just get started. So, is your Git clone done?
Yeah, and it's open in VS Code.
Okay, excellent. So what I want you to do is, where was it? Okay, so I want you to go to Unity and open up ML agents.
So when you say add, does that mean click add or do you?
Yeah, no. So you click add,
Yeah.
and then you click on dev projects. Where was it? No. I just had this open a second ago. Let me figure out where it was.
All right. So I added the ML agents. Invalid project path.
Yeah, so like we need to add the specific. So this is because this is like has both the Unity project and it also has some stuff related to the open source project. So go to ML agents dev project.
1 sec. How many live viewers do we have right now?
We have 4 viewers. A minute ago we had 8. So
Okay.
yeah, like typically people just need like a couple of minutes to come in, but we'll humor them.
All right.
Okay, so I want you to go on like dev ML agents project.
I want you to. What is this? A code with a client?
Yalla.
Right. Simon code dev projects.
ML agents projects, and then go to assets. ML agents examples. Worm.
Yeah.
Scenes. Oh no. Actually, yeah. So once you're in Worm, I think we can just select the folder. Oh, it's still saying invalid project path. So you used to be able to add the scene here. So let me just figure out what's going on.
The scenes folder seems empty.
Yeah, that's weird. So there's an alternate way to do this. So I would just instead of opening it via Unity, just go to your like open it in your Finder, and then do the same thing. So project, assets, ML agents, examples, worm, scenes, and then like worm. We're gonna open up worm static targets.
1 sec. This is weird. My worm folder is empty.
Yeah, so this is if you're it should be empty if you're opening it within Unity, but if you open it up within your Finder, it should have something there.
I see what you mean. Yeah.
Why is this not opening though?
So am I opening the dynamic or the static target?
It doesn't matter. I would open up the let's do dynamic actually. I think that's probably more interesting.
Yeah.
So worm, and then scenes, and then dynamic. Okay, it's just taking a minute to load.
If anyone's watching this, donate $5. Don't be stingy.
You should apply that to yourself, my dude. Firstly,
this is a tutorial. This is a tutorial for that people would pay thousands for.
Probably.
Yeah.
All right, so it just takes like a few minutes to load. Like it's sort of really slow starting off, but it gets less painful like once everything loads.
If I wear a low cut top, will we get more donations?
Probably yes.
Okay, I'll take my shirt off halfway through.
Like we should definitely try to go into the OnlyFans channel on Twitch, like the thoughts. Definitely think it would be easier to get a more loyal following if we were thoughts. All right. So this is still loading. It's busy for another 45 seconds. But like once this opens, like I want to just kind of go through the project at a very high level before we run anything, so we just know what's going on. Yeah, ideally, I think maybe as a pro tip for next time, we should just open up the projects before the stream. It's crazy. Like, I mean, I have like a Threadripper, and this is still taking like forever to open.
Yeah, I mean, for me, it's still resolving the packages.
Oh, okay. Yeah, same here.
And bearing in mind, I don't have an RTX. I have a 670.
Yeah, like GPU doesn't matter all that much here. It's like I think it's more bottlenecked by CPU. I mean, let's see.
Or I could get an IPU. If
Ooh.
I'm bottlenecked by neither.
I mean, yeah, check this out, dude. Like, I'm at 20% utilization with my CPU. I do like, why doesn't just like take everything? Like, just eat everything you find and then just do it. Versus memory is like 50%. Okay, it opened up. So excellent.
Nice.
This worm is cute though. Let's see. Does this work?
Let's call it Tekka.
Tekka. I got black. I got white. What she want?
Yeah, it's a gangster
Okay.
worm.
Look, it works. So, oh, so do you see the worm slithering around?
Yeah. So is that like the reinforcement learning with like the box with two arms that's figuring out how to crawl?
Yes. So basically, the box is the target, like where it needs to learn how to go. And then like
and it's just trying random things.
No, not yet. Like in this case, this is already pre-trained. So I can show you how to train it from scratch as well. But like basically, let me just talk about this for a second here in a drawing. So typically, the way this works is Unity here will basically talk to a server that's like a Python server here. So let's call this like the Python Unity ML agent server. And what this server takes as input here is it takes in like, let's see here, like it takes in like the environment state. And then it returns back an action to take to Unity. So yeah, so let's do this. Right, okay. So it's gonna take in like so at every point we're gonna feed it the environment state, and the environment state is literally like the variables that fully yo, hey Mazen, nice to have you on chat. So then what, like the environment here, like let's kind of think about this for a second. So if you go to the scene view, did it open in your
No, still loading.
Still loading?
Keep sharing on your screen.
Okay. So you'll see here, like, we'll notice something interesting. So if you go to the scene view here, you'll notice like there's the worm, and then there's a target. But what you'll also see here is like there's like a whole bunch of other worms. I don't know if you see them with a whole bunch of other targets. The reason we do this is like this sort of lets us parallelize the training, where you could have all of these worms collect experiences, and then it trains like a lot faster. So like let's say in this case, like what is the state? Like on one hand, like the state here is the environment state. Like if you click on this green square, you'll notice here to the right that it has a position. So it's centered around 0, 0, 0. It has a rotation, and then it also has a scale. So this is the state. It's basically this, like you feed them these variables, and the environment thinks, okay, well, given these variables, and then some variables specific to my worm. So let's see how the worm is defined now. Why can't I click on the worm? Okay, so let's see here. So there's worm settings, main camera. Okay, the directional light, the worm
Yeah.
settings. Okay,
I
the
can see
water.
the worm on my screen snuggling with the block.
Excellent.
If anyone's watching, I'd highly recommend you do it on your screen because it doesn't do it justice with the low frame rate of the screen share.
Oh, yeah. I mean, for sure, like
Really
this is a
fun.
lot more fun to do it yourself. Okay, so let's look at how a worm is defined here for a sec. So typically, Unity has this programming model called component-based programming, and what that means is that you define an object, and then you add certain behaviors to it. So, for example, here, like the worm also has a transform, as in transform is basically your position, your scale, and your rotation. Like it's just shorthand for all of those variables.
Mm-hmm.
So it's basically a 9-dimensional vector that defines your shape in some sense. But after that, like, we'll see there's some other stuff. There's this behavior parameter called worm dynamic. It looks like it's doing some inference on the CPU. There's the worm agent itself. Okay, so like now this is making more sense. So like let's say if you go to the worm agent script, you'll see that the target is defined to be this target transform. And if we go to this target transform, it maps to the square we're trying to go to. So really here what we're trying to say is like we're telling the worm, like, look, your goal is to go, like your target is this is this green square. Like that's where you need to go to.
Mm-hmm.
So interestingly enough, if you go here, you'll notice that like a cube, like what does this cube do? Like it has a mesh. A mesh is just saying like you have a shape. So the shape here is very simple. It's a square. But a mesh could be something more complicated like a face, in which case it would be many, many small cubes all interspersed and rotated and deformed. And that's kind of what 3D modelers do. Like they build meshes for objects. Other stuff you'll see is a mesh renderer. So a mesh renderer lets you color things. So for example, here it's saying like, well, it's green. But you could, for example, like make it blue, or you could make it like a checkerboard pattern or whatever. So this is like, I mean, if like this is more if you're actually making a game, and if you're an artist, like this would be where you would come in and start changing stuff. But the interesting one, like all this is irrelevant. Like let's say for reinforcement learning, none of this stuff really matters. The only thing that matters here is that this is a rigid body, and a rigid body means that this is a physical object. Like it has a mass, it uses gravity, and specifically you can collide with it. And you notice like when the worm was like walking into this thing, so if I'm click play again,
I'm doing the same here.
yeah, so once you click play again, you'll notice that the worm actually does end up colliding with stuff. So you'll see here it comes in, and you see it's like pushing the box, and had we not had a physical collider, it would just pass through it. Similarly, like the ground is also has a physical property associated with it. Otherwise, the worm would just like fall through the floor.
Yeah.
So one cool thing, and you'll see here like this inspector here to the right, it's updating the position of the target. Like the target is being pushed at every point in time.
Yeah.
And so this is sort of a hint where like now if you want to program stuff, you can basically just inspect the state of those variables on any object. Like whereas like let's say you're designing an RPG and you hit someone, you can be like, well, like if they move from their position, therefore it means they were hit, therefore like decrease their total HP, and if their HP is below 0, then make them disappear. So this is how you end up programming a lot of stuff.
No, that's really interesting. I mean, in mathematically, it would be a nightmare to program a collision. Well, very difficult with a cube, and nightmare with random rigid body. So really cool that Unity does this.
Yeah. So like, and to kind of make the point here, like if you go here to like let's say rigid body. Okay, so it already has a rigid body. Like yeah, that's sort of like the main thing that Unity provides you. It's that like you don't want to sit and make a game engine from scratch every time you want to make a game. So it just like helps you not have to worry about this stuff. The nice thing I also like about this is that like you see here the camera. So you see how this is a perspective camera, but if I made this an orthographic camera, then now all of a sudden you have a 2D game with the exact same code that you use to make a 3D game. So like let me show you here. So this is like a fixed angle, right? And so it still, and if you make the worm only be able to move in one direction, then you end up with a 2D game. like this. So sort of like this is, and there's some games that I think do this really well. So for example, there's a game called Nier Automata. What they do in that game is that like angles change basically while you're fighting, and the game becomes a 2D game versus a 3D game. And whereas that looks like it's a nightmare to program, it's actually not all that big a deal if you're using a proper game engine. So let's go back here to perspective.
This is really cool. I'm just trying out orthographic on my screen. No, really, really clever. Man, how long has Unity been in the market? So it's pretty amazing.
It's been for a long time, I would say. Like let's double check. So Unity release date. Oh, I see. 2005.
Wow.
Yeah. So I will say, for example, like a lot of game engines came about from games. Like let's say Unreal Engine came from Unreal Tournament. But then they realized, like, wait a minute.
Actual game.
Yeah, like it was amazing too. Let me show you.
By the way, Mark, what's your username on Twitch so I can find the stream?
Oh, it's a Formal System.
Right.
Yeah, so make sure to just mute the chat there also, or else it's gonna echo through your voice as well.
Yeah. Great.
All right. So you'll also notice here, like I just want to show you some small interesting stuff that like why do I like Unity so much? So you see here, for example, there's a like I'm just gonna pick something arbitrary. Like you may have noticed that like when the worm moves. And honestly, this is a lot how I program, by the way. Like I'll be like, oh, like how does that work? And then, just get curious about it and then forget the whole point of my original programming session. So you notice like the camera's following the worm, right?
Yeah.
Like that's not a coincidence. So if you go here at the camera, they've added the script to the camera called camera follow here. Oh, actually it doesn't show. I'm just going to make my head smaller on stream so that people can see more stuff. I'm gonna do the same with yours.
Yeah.
All right.
Okay, and then so I'm just trying to follow along with what you're saying. So all right, I'm clicking on camera. Right, camera follow.
Okay, so double click on camera follow.
Oh, you can see the script here. Oh, really interesting.
Yeah. So basically, so this is how you hook up intelligent, like how you hook up scripts to your objects. So here, for example, like let's look at something as simple as camera follow. Like let's think about how this works. And you'll see here it's just 26 lines of code. Like it's nothing all that crazy, but it's very instructive as to how Unity generally works. Like basically almost every single Unity script will have a start script and then an update script. Like why? A start script is basically you're saying, okay, well, as soon as this object is created, what should these variables be? And then update means at every frame, like what happens? Yeah, so this isn't C++, Mazin, this is actually C#. Like if you like C++, you could use Unreal Engine. I think it makes it easier. But I mean, yeah, the code does look very similar to C++ at this point.
So here it's interesting. It's updating the X and the Z offset, but it's keeping the Y fixed. Is Y the vertical axis in Unity?
I mean, yeah, like basically it doesn't want to move the camera. So basically the Y is going up. So it doesn't want to move up and down. It just wants to move to the side and forward and back.
Oh, right. So Y isn't always vertical. It's relative to the... Oh, you can see it on the top right. I see it right here.
Yeah, so this is your coordinate axis. You can see it here.
Yeah.
So if you hold right click on your mouse and move around, it lets you move stuff around.
Yeah. And what I'm gonna have fun doing is changing the offset. Oh, right, and it shows you if you move the camera around in orthographic mode, it shows you how it changes the perspective.
Exactly.
Really cool.
Okay, so let's look at how this works. Like, so I mean, at a high level, like we're in a camera, we want to follow something. Like the script is called camera follow, and it's taking in as an argument body seg 0 transform. So we just said transform is shorthand for the position, scale, and rotation of an object. So like, let's say if I double click here on body segment transform, then it's basically following the top part of the worm. And then, interestingly enough, like if you look at this worm, the way they've made it sort of squiggle is that it has this zero body segment, it has this one body segment, the 2, 3, and then it has the eyes. So the eyes don't look like they're doing anything, but the way that we've been able to program this sort of worm-like behavior is by having 3 body segments. A natural question is, why not have 100? It'll look more natural. Yeah, why the fuck not? You can just do that and it would probably work just fine.
Yeah.
So
I'm guessing that Unity will start to crash at a certain number of objects, and thinking of a game like Factorio where you have easily 100,000 or even 1 million objects in your game, can Unity handle that volume easily?
Yes. And the way it does this is basically with this programming pattern called the entity component system. It's sort of, as far as I'm concerned, it's sort of like the design pattern to end all design patterns. But the main idea is this. Like, as opposed to having one central game loop manage the state of all objects in the game, you turn every object into the game into a server. So let's say in the case of Factorio, like you have like a smelter. Oh, thank you. Like we have a new subscriber. Let's see who they are. Oh wow, 2 subscribers. Like thank you MP90 and thank you Mahad. Let me know if you guys have any questions. Oh wow, even more. Yeah. So the way entity components, like let's say take the example of a smelter in Factorio. A smelter manages its own state. It's gonna think, oh, I'm getting some ore, and if I have ore as an input, I'm gonna produce steel plates as an output. But the game itself doesn't need to manage this. Like each of these entities is its own server, and this makes it a lot more tractable to scale up, behaviors and make them something really complex. So in Factorio's case, they built their own game engine. But in their own game engine, they would still need to emulate a pattern like this. But what I like about Unity is that it makes this pattern a first-class citizen. Like each of these things here you're seeing on the left in the navigation bar in the hierarchy is a server.
Yeah.
Interestingly enough, like when people talk about reactive, oh wow, we have 15 viewers right now. This is crazy.
I'm looking at it on Twitch.
Hello, okay,
everyone. So for the new joiners, just to welcome everyone, Mark and I are childhood friends. Mark is a career developer. I am not. I am a self-taught developer and only started teaching myself 2 years ago. So Mark is taking me from virgin level to Chad level in Unity ML learning in just an hour and a half.
I'm glad to. We'll probably go on. Like maybe we'll go on for longer at this point. But anyway, let's go back to. Yeah. Let's get back to work. Stop procrastinating.
We're going to have an interruption in 20 minutes because my computer has to restart.
No.
My level of computer expertise.
No,
right.
Not acceptable.
So back to what we're looking at here. Let's say I wanted to edit this code that we're seeing here. Like, let's say I wanted to change the Y offset as a function of the position just to make it kind of like pan out every time the worm moves.
Sure.
Am I able to edit this code?
I mean, yeah. So it would basically be here. You see in the new position.
So I'd have to open it in Visual Studio.
Okay. So it's already open on my screen.
Yeah, I have it open.
Okay. So first off, you'll notice that it inherits from this thing. So we have the class called camera follow. It inherits from mono behavior. Think of mono behavior as we want this to work in Unity. Like it's just like this thing that you add. And the 2 variables that we're keeping track of are the target, which is the thing that we're following, which in this case is the top part of the worm, and it's the offset. So the offset is the distance between our camera and the worm. And so you can see that here is that when we're computing the initial offset when this starts, we're looking at the transform of the game object, like of the target. And then we're subtracting, so here it's saying so this is the current game object, and we're taking its transform dot its position, and we're subtracting that from the target position, and this gives us a distance. So this is just using like very straightforward like vector math, but if you're taking the difference between 2 things, you're getting the distance. So we have a question from Krishnan. So awesome, looking forward to the talk. Would you be able to cover the Python side of ML agents? So the different algorithms, and does it still use PPO? I mean, yeah, I'm happy to cover the Python stuff. So I think what Krishnan is asking, Cab, is basically, can we sort of cover how ML agents works under the hood? I think I'm happy to do that, but we'll cover that last because I want to cover all the Unity specific stuff, and then we'll go into the Python specific stuff. That's totally fine. So basically this gives us an initial offset, and then you'll see here at the new position, we want to update the position of the camera at every step, right? And then here you see, and it's using some sort of complicated formula. We'll look into this formula and figure out how it works. And then it's updating the position of the camera to this new position. So let's look at this. It's creating a vector 3. A vector 3, I mean, as you know, Cab has like an x, y, and z component. And the way they're updating the x coordinate is they're saying it's the target position, x, plus the offset at x, the target position at y, and then the target position at z plus the offset at z. So this doesn't look really hard. Like, you tell me how to change this to also update the y coordinate.
Yeah. So I'm guessing the target position changes, but the offset is constant because we're initializing it at the start.
Exactly. No, yeah. So you know what this is.
Here's what we can try doing. Let's try adding the offset. Let's try adding the x offset to position y, which is basically saying or rather, let's try adding the position x to position y to make the camera slowly pan up or pan down every time the worm moves. It'll be a very ugly effect.
Wait, so what are you saying? So, okay, so which of the three coordinates do you want me to change? X, Y, or Z?
So that's the y one. Let's change the y one, and let's just add target.position.x to it.
Oh, okay. I don't know. Let's see what that does.
So it should, every time the worm moves along the x-axis, make the camera go up or down.
Okay. So I just hit Control S. You know, this looks fine.
Yeah.
I have no idea. I'm trying to predict how this is gonna work.
Yeah.
Okay, Unity is refreshing.
Ugly,
let's see.
I'm excited to see this.
I would say that's fine. Like, a big part of understanding how these things work. Okay, yeah, it just doesn't do. Okay. You see how this is doing? It's like very quickly like scanning through the screen. So like this would be like, I mean, if this was in a real game, like this would definitely be a bug, and then you just like need to figure it out. So let's try something different. I think as a more straightforward thing to try out, what if we just try it out here, like the m offset dot y, for example. Like, this sounds like a more reasonable thing to do. So I'm gonna Control S, and then this is gonna reload the scripts again. Let's see how this works. Oh, it's also crashing. Interesting. Wait, let me make sure.
I think it's not that it's crashing. It's just that the m offset y just happens to bring the camera below the ground. So if we try subtracting offset y, it might give us something different.
I think it would go down in that case. Let's see. Because I think this was going up. So if you do that, the camera would just go below the screen. And I think that's probably, it looks like, why they're not updating the y-axis. Because you just can't see the result. Yeah.
Well, they're not updating the y-axis because it's 2D, right? So you want the y to stay constant as it's moving around.
Yes.
But I'm just wondering what changes every cycle. So the m offset looks like it's staying constant because we're just initializing it in the beginning. Target position.
Oh, no. Wait. No. The offset isn't the same because your position changes at every step, right?
Sure.
So.
Oh, but here we're just setting. So is the start called every cycle?
No, start is just called at initialization, and then the update is what's called once per frame.
Right. Yeah. So offset is constant, right?
Yes. So m offset here is constant. Yes. Oh, I see what you're saying. So we want the difference to always be constant. That's why we need the position to change.
And it just follows the x and the z of the worm.
Yes.
What I think is strange though is why, like, wouldn't the y be constant? Why is the y changing at all? Because the y coordinate of the new position, we're changing it every time.
So I think like that relates to the physics of the worm itself. Like, it is slowly moving up and down, and when it does, it's sort of creating like this nasty effect.
Yeah.
Because it's not a 2D object; it actually has like physics involved.
3D that we're just following constantly from
Yeah.
the top. Cool.
So let's try to see what else is going on here. So if we go here, let's say, okay, so the worm prefab dynamic here. Oh wow, new subscriber. I want to say thank you. Thank you.
X MadFad.
Yeah, and it's also the Prime subscription. So XMadFad is also like, helping actually support the stream economically. Thank you, XMadFad. Appreciate it. Okay, so let's look at this. So we basically have this. Like, first off, we had this worm agent script we talked about, right? And then it had, like, let's say the target, it had the ground, and then it had these body parts that we talked to. And then you'll see here that it has some reward functions. So I want to go into worm agents because like now we're going to start covering the reinforcement learning side of stuff soon. So let's look at this. So it's saying that you want to reward the moving the moving towards the target. So okay, let's say I want to reward you for you yourself, Cab, getting closer to the target. So the idea is that I can reward you proportionally to the negative of the distance between you and the target. So the closer you are, the more I reward you, and the further you are, the less I reward you. So I want to reward you for moving close to it, but I also want to reward you for facing it. As in, if you're very close but you're facing the completely opposite direction, I want to tell you like, hey, like, don't do this. And so all of these stuff seems to be specific arguments of the worm agent script. So is this stream saved? Yeah, so Omar, I am going to be uploading the stock later to YouTube. So on YouTube, I'm not called Formal System. I'm called Mark Seraphim. I should change that. It's just my first name, last name. But yeah, like I'll also be uploading like a saved stream on my Twitter. So if you ever want to go back, like I'll have a good summary there. But in the meantime, like since you're here, if you have any questions, just like let me know. So yeah, so let's go to the worm agent script. And we see like immediately this is a much nastier, more complex looking script, but I think we'll learn like more going through it. But okay. So first off here, let's look at this. Okay, first off, this is saying it requires a joint drive controller. And we're like, okay, well, what's that? And I just want to show you the joint drive controller here. So the joint drive controller is basically the physics engine, like the physics part of how do you make the worm move. And so let's go through it at a very high level. Like you'll see here that it has a starting position. There's also a quaternion for the starting rotation. Okay, Cap. So people love quaternions in game dev because it lets you do rotation math a lot more easily. Like let's say you want to add rotations or subtract rotations from each other. You don't end up with undefined behavior. And so that's why it's pretty popular. And so, like, let's look at what this is doing. So it comes in and then, let's see. So here there's a body part. And if the body part is touching the ground, you'll say, like, it's not touching the ground. The target is not on the ground. And then at every time step, you want to set the target rotation. And so you'll see here that what they're doing is that they're initializing the X, Y, and Z rotation. And then they're doing this thing called Lerp. So Lerp is a smooth, and like, I'll just maybe show you on Wikipedia this algorithm. Interpolation.
Is it just to smooth out the animation?
Exactly. Like it's a sort of a mechanism like on which you can like smooth stuff out. And so you'll see here, like then they come in here, and then like let's say when it comes to setting the joint strength as well. And then like dampening the strength so that it, I don't know, uses like some. So again, like this is also like a way to make it smoother. And then like
when you say dampening the strength, what are you dampening here?
So
like to make the worm move, just not like in several disjoint movements, but in a smooth way.
Exactly. Like as opposed to like the main idea here is that let's say you tell the worm like move to position. Like X, Y, and Z, right? Like it has some sort of target position. You could either explicitly tell the worm, like, look, if you're at this frame, now just all of a sudden teleport to this location. Or you could tell the worm, like, look, given that you need to be at this XYZ position by time step T, what are all the steps that you need to take to make this transition smooth. So this is like another thing animation software is very famous for, to sort of make this part a lot easier. So you basically set the target, and you'll actually see here, like there's this animation curve here, and you see here they're adding a key. So they're saying like, I just care about the force on this joint to be this at this time step, and then you figure out the rest for me. So I mean, actually, like if you've even done an animation in PowerPoint before, they'll have this. Like they'll explicitly come in and they'll say like, look, I want this. I want the position of this object to be XYZ at time step T. And now you, PowerPoint, worry about the rest. Unity does the exact same thing. It just looks a bit more complicated because obviously this is a more complicated object. It's a 3D object. It has multiple joints. It has 3 body parts. And so setting up all of this stuff is a bit more involved, but like mechanically it comes up to the exact same thing.
To tie this back to reinforcement learning, I'm guessing the force you can apply on a joint is the action. And presumably you don't know when you're starting out how applying a force to this joint is going to make the worm move before you train the
Exactly. So what you're gonna do is at every time step you're gonna apply, like let's say initially you don't know what's good, you'll apply some random forces. You apply these random forces and then you're gonna get a reward back. Your reward is basically your distance from the thing. So if your actions made you closer, go closer to the target, then you get rewarded. And if it made you go further from it, you're basically punished. Over time, your actions get less random because you want to get closer to the target. And so this is the...
Are we doing Q learning here, or is it another kind of thing?
So it's another kind of algorithm. So Q learning in particular doesn't work in continuous domains. So in this case, because there is an infinite number of actions you can take, because we're working in a real space. So let's say you have 3 joints, and each of these can take a real number of possible forces on them. Then your state space is R to the 3, which is infinitely large. You can discretize it, and then use Q learning. Like that's totally valid. But as opposed to discretizing it, there's algorithms that natively work well in the continuous domains. Most famously, DDPG and PPO. And as Krishnan alluded to earlier in chat, like PPO is basically the default that Unity ML agents uses in everything. And so after we're done with the C# stuff here, I actually want to show you how Unity ML agents implements things under the hood, and how like they tie this back to some Python code. So let's go back here, and we'll go here. So like we'll go to the worm agent here. So you'll see here the worm agent inherits from something called an agent. And an agent is basically a Unity ML agent specific class that tells you, I want to add intelligence to this thing. And so what does the worm need to be aware of at any point in time? So it needs to be aware of, so you'll see here first off, you see how they have these header, like target to, and then they have some space here. Like this looks weird, like this kind of looks like some CSS or something, but it's in your Unity ML agents code. The reason they have this stuff is because when you go back here, this is the target to walk towards. This is the target to walk towards. And then they have the public transform. And so then, yeah, you'll see all of this stuff shows up here. So the reason we'll add these headers is basically so that we can change our public variables from within our Unity graphical editor. And so eventually, like, let's say, how does this work in a real game? Like, let's say I want to make a game with my sister, Sarah. Like, Sarah's an artist. Like, she doesn't care about code. I don't want her to come change code to change the behavior of the game. I want her to just come in here and change stuff. And so this is how I would make her life easier, and how the boundary between developer and game designer gets drawn. It's like dump it in the Unity UI. So you'll see there's also a bunch of other stuff. Like there's the body segments, for example. So these show up here. And then we'll see here there's actually the reward functions to use. So the reward moving towards target, the reward facing target, and then the reward time penalty. So let's kind of think about these one by one. Like why are these all here? So usually if you go over any reinforcement learning tutorial, you'll get this reward moving towards target. And so this is what this is here. Like they're just checking it. So it's a Boolean in this case. So that's why it became a check mark. And what's up with this time penalty? Like this one sort of makes sense, I guess, right? Like you just want to get closer to stuff. But this one, it's like, why is there a time penalty? So the idea here is that there's, oh, Sarah's also in chat. No code for me. Yeah, definitely don't want code. We just want you to just have fun making a game. So what's up with this time penalty thing? So there was this early reinforcement learning experiment people did where they were doing reinforcement learning agents on a multiplayer version of Doom. And so the way they encoded the game was if you get a kill, you increase your score, and if you die, you decrease your score. What ended up inadvertently happening after training these agents for a long time is that the agents decided that the best way to increase your score over the long run is to just not play. Like they literally discovered peace as a way to, play the game, because they're like, well, like, there's a sort of inherent risk with trying to kill people, so let's just not kill people. So but that means if you as a game designer want to encourage like your agents to actually be good at killing, then you want to punish them for the amount of time that they take for doing nothing, and that's where this reward penalty sort of became a staple in reinforcement learning algorithms. So
is this the same as a discount factor?
No, so a discount factor is different. Like I can see why you think they're similar. So the way a discount factor works is you would rather have rewards now as opposed to have rewards in the future. Right. And so you basically exponentially decay futures that are coming later in the future. I guess by that logic, yeah, they are kind of similar. Like, and I can see why you would think they are. But I would say like that's not how people thought of them, I guess.
But I can see the difference, because the discount factor wouldn't account for the Doom example you gave. Because in the Doom example, they'd still have to, even if you had a discount on a reward, they choose the 0 rewards if they're
they're like in the long run, peace is still the best thing for us to do.
Exactly. So no, that's a really helpful example to see how they're different. And then a couple of questions here, right? So they're giving a reward depending on whether it's facing the target or not. When you're doing reinforcement learning, don't you want to be as little prescriptive as possible to what the worm is doing? Shouldn't you be saying, for example, distance to box, or if you touch the box you get a reward of 1, and if you didn't you get a reward of 0?
Excellent point. Excellent point. This is a great question. So this gets into a whole debate around how to design reward functions. Interestingly enough, this is not something reinforcement learning researchers seem to care about. It's only people that design games that ask this question, because it's a very natural question. Ideally, you just tell it where the box is and you give it a Boolean reward, and you tell it if you hit the box, you get a reward of, let's say, 1,000,000. Otherwise, you get a reward of minus 0.1 at every time step. So I slightly punish you for not being close to the box, and if you're close to the box, I'm like, great, you won. The problem with this is that you end up with something called sparse rewards, which is when the agent is taking actions, it can't associate its actions with what's actually better at any given time. It can only do that at the end of an episode. And so while, yes, from an intelligence standpoint, that is the best thing to do, to give it just the end goal it needs to resolve, practically giving it these dense rewards, even though it's more upfront cost for you as a game developer, ends up making the training a lot faster. And if anything, the main reason why reinforcement learning isn't the sort of standard thing that everyone uses in games today is because it's very expensive and it's very slow and it's not reliable. And these are tricks to make it more reliable.
Sure. So basically you're sacrificing, the possibility to discover some amazing unexpected behavior that makes it win for speed.
Exactly.
Makes sense.
Yes. So let's look at like how this works for now. So like let's say typically in Unity, like let's say here we saw that there's a Boolean reward moving towards target. So I'm just gonna right click on this and then find all references. And so I just end up with one reference that shows up, and it shows up here. So if reward is moving towards target, and then we have this like, okay, reward function moving towards. Okay, let's see. Where is this function defined? Okay, great. It's defined here. I'm gonna say go to definition. Okay. So this is how this is defined right now. You'll see here, basically we're taking the dot product between the direction to the target and the direction of the body part. And if they align closely, that means that you're heading towards the target. That means you get a small positive reward that we scale, because if you're just going to give it the distance, it's going to be a huge number. So you just like scale it by 0.01 here. But this was actually the one I wanted to look at. I wanted to look at the other one. I wanted to look at
But this is really interesting, because what you're saying is that you're not seeing how far it is from the target here. You're saying, is its whole body moving towards the target?
Yes.
Because you could have, I suppose, its tail is moving towards the target, but actually its head and its midsection are moving to the right, so you lose reward.
Exactly.
Really cool.
And so you could imagine, instead of this, so let's go back to the reference here, and then go back to the definition. You could imagine other ways to have this reward. Like, for example, your reward here, like you could say, for example, this is basically distance. And then I could say this is going to be the, like, let's say the target minus the game object dot position, dot transform dot position. And then I add a reward times the distance, right? So this would be like another way to sort of create this reward function. That would be totally valid. What's better? Like, you just need to try stuff out, like, and then just see what converges like faster for you. Okay, so let's say, for example, here, like you'll see, okay, this time function penalty. You see how this works? Like, at every step, just give it a small negative reward. Do you hear me, Cap?
I do now. I was signed out because my computers are starting. But
Oh, okay.
The show must go on.
Okay, do you need like 2 minutes? Because we could take a quick break.
No. I can follow on my screen.
Okay.
On my phone screen.
So let's look at what else is going on here. Is there anything else interesting going on here? So fixed update, touch target. Okay, yeah. So this one is interesting.
The touch target function.
Yes.
The target is a rigid body, so I'm curious to see.
Yeah. So basically, let's look at fixed update. So fixed update basically is just a way to say at every time step, check this function. The difference between fixed update and a regular update is that this isn't dependent on your frame rate. That's like a very common bug that happens when people first make games, is that, let's say I have a faster computer, then my code ends up becoming faster. Yeah, so you're currently sharing your screen cap. Do you mind just putting your face again?
Yeah, I'm being disconnected from the call. I don't know what's happening, but
okay.
Just go on. I'm sure that the streamers are.
No, you're back. You're back.
Let's see what's happening. So don't
okay.
worry about me. Just go
so let's look at this. So first off, we're like, well, if we detect a target, then we go into this loop. So what's detect target? Like, let's go to the definition here. Okay, so it's a Boolean. Okay, great. Where are all its references? Okay, so maybe it's set up here. Detect targets. Yeah. So it's a Boolean that's set to true. So okay, so first off, there's a question. So Cap, while you're doing your technical glitch, there's a question from chat. So what do you think of the new Minecraft challenge by Microsoft? So for those of you that don't know, like recently Microsoft is sort of trying to make Minecraft sort of a first-class environment for reinforcement learning, like where you can define all sorts of tasks, like let's say build the largest structure or get the most diamonds, and then, unleash a reinforcement learning agent on this. And while I do think it's a valuable effort, personally, I kind of don't care about this effort, because I don't think optimizing over other people's reinforcement learning benchmarks is particularly interesting. What I find a lot more interesting is creating your own reinforcement learning benchmarks, which is why I'm doing this sort of tutorial in the first place. I think make your own game, don't use other people's games. So we're back to...
So don't do what we're doing and use the Unity worm example.
Exactly. So here we're sort of covering what we like. It's sort of a tutorial, right? But ideally, I would like you to just make your own environment. So let's go here. So let's see, we're at touch target. So for example, this is saying for each body part in the controller, if the body part contacts with a target, then we trigger an event called touch target. So touch target is a function where if it gets called, you basically add a big reward. So remember, all the other rewards we were working with were 0.01, whereas here it's 1. So it's a reward that's 100 times bigger. And as soon as the target gets hit, we randomize the position of the target again. So we restart the environment basically. So this is what's happening here. So if any of the body parts of the worm hits the green box, you give it a big reward, and then you randomize the location of the target to keep going. The reason we do this is because if you basically give a fixed position for your algorithm, like you just tell it, go to this XYZ location where the box is always going to be located, what's going to happen is that the worm is going to memorize going to that location, and it's not going to understand that I actually need to go to the green box. And so this is another. Really interesting. So that's another thing that you need to add here.
Yeah. And where can we see the function that determines how the worm touched the target? That's what I'm really interested to see.
Yeah.
Because here it's simple. It's a box. But let's say it was a blob, right? Like it's hard if you're just doing simple vector math to know if an object touched the blob or not. So I'm curious to see how they define it here.
Yeah. So let's see. So they're saying if body part target contact. So let's look at target contact, how that works. It's not here. Okay, so first off, like what's body part? So body part, so here we have in the joint controller. Let's go to the JD controller. Okay. So in this joint controller, now I'm going to go to definition. Okay, wait, I think it was all here. Yeah. So where was it? Joint controller. Yeah, so I would need just like a minute to look at it, but let me just show you. Like, let's say Unity rigid body collision. So unfortunately, like I think you just asked an interesting question, because Unity is not open source. So if you were to want to go to the actual collision code, it may or may not be there.
Right,
so okay. Whereas like other engines like Godot, for example, are open source, they're harder to use, but then that stuff is all there. So you'll see here, for example, that they literally have like all these scripts for like a box collider, a sphere collider, a capsule, an arbitrary mesh, a wheel, or a terrain. And so what literally happens is that you would just say like if collision with this object is equal to true, therefore trigger this event. So as far as you're concerned, all of this stuff is abstracted away from you. And if you wanted to build your own collision engine, you are right, it's actually challenging because it's highly dependent on the shapes that you're working with. So you would need to program each shape.
We don't have to go into the detail of the code. I was just really curious to see where it was in the script you're looking at, and you answered the question, right? It's that it's not at all trivial. So it's not like, oh, it's a few lines of code that will insert in the script right here. We'll just use Unity's pre-built collision engine.
Yeah, that said, I will say that there's a book I really enjoyed, Game Engine Book Physics. I think this is the book that helped me understand collision. Yeah, this one, the Game Physics Cookbook. Even though this book just has 3 reviews, I think it's excellent. It goes over like basically all of the collision math that you would ever care about ever. And they did a really good job. And this is what most game engines do. So it's like, but that's a common thing I noticed a lot, depending on the kind of person I talk to. Like when you're first trying to make a game, if you're drawn to making a game engine more than if you're drawn to making the game, like that says a lot about you. It's that maybe you just think this is more interesting. And so maybe you're not a game designer, but you'd be a great like game engine developer or physics developer or whatever.
Yeah, I would definitely see myself as more of a physics developer than a game developer. How
Yeah,
about people in the Twitch audience? Comment in the chat what you would prefer
comment
to
below.
cover that.
All right. So let's just keep going through this. Like let's say here, okay, like there's like another function that we haven't taken a look at, which is the decision requester. So what is this? Okay, so this is new, by the way. Like this wasn't here last time I used Unity ML agents. But basically, they're saying like they want to set a frequency by which the agent requests a decision. So here they're saying like we want to request a new decision every 5 steps. So basically, the agent is just going to do its thing, and then every 5 iterations, it's going to tell the basically the reinforcement learning server like which action should I take right now.
Very
Uh,
interesting.
and then it's going to come in, and then okay, so this is basically the academy. So the academy is basically setting up the server that comes in and says, okay, like start doing reinforcement learning stuff, and then I want to make a request from this, and then you come in. So I think now that okay, so maybe like I think one thing like so that we can kind of do more interesting stuff here.
So, question mark, if you
Yes,
go back to your diagram, because I think this will be useful for the viewers.
the one I did in Google Drawings.
Yes.
Okay.
Yeah. So I'm looking at the diagram below. So it's Unity that's requesting, it's sending the state to a server that's owned by Unity,
Uh-huh.
and all of the like sort of heavy machine learning processing is being done by the Unity server.
Uh-huh.
Is this free? A free service provided by Unity?
Okay, so it depends how you define free. So, and actually, like also, there's Krishnan in chat that's also asking, like, what the hell do we mean by server here? Okay, so literally, what we mean by server here is if you literally, you know, it's literally like a Python script. Like I'll actually show you. So Python HTTP server. One moment. Yeah, so it's literally Python -m simple HTTP server.
Right. So
And
this server is set up on your local machine.
correct.
Right? Like, yeah, it's Unity said, okay, got, yeah,
Correct.
that answers my question. I thought
Oh.
it was some online server that
Oh.
Unity provided.
Yeah.
A bit like Colab notebooks. But it's not. It's one
But
on your
they
computer.
recently collaborated with Google to offer a cloud-based offering where you can do this. They call it Unity Cloud Simulation. And so you can do the exact same thing on a server. And odds are for any game that's reasonably complex, you will need to do this. Like it's not at all trivial to get these things to scale locally. And yeah, but like what we mean by server here is like we're running a simple Python script. And this Python script, you can sort of think of it like a sort of Flask server or a Django server. It takes in as input the game state, like the environment, like the position of the worm, the position of the target, the instantaneous reward, and did the worm actually touch the agent? And what it gives as an output is an action. And in this case, and usually an action would be a discrete step. It could be like go up, go left, go right, go down. In this case, an action is 3 real numbers depending on how each part of the worm was moved. But to sort of make this point clear, because maybe a worm is kind of complicated to think about, like let's do another example. Like let's say you want to play tennis, for example. So here I'm going to the tennis example. So let's see how this works. Okay, so you'll see here, like this is playing tennis. You know, you'll see there's like a million little tennis servers going on. They're all collecting observations, and they're like pushing the ball at each other. So let's kind of do
another question here. Like I get the advantage of having like 20 or even 100 simultaneous agents being trained.
Uh-huh.
But again, from the very little I know in reinforcement learning, you train it kind of without rendering the graphics because that's really expensive. And then once you have the trained model, you look at it in this UI visual graphic output.
Uh-huh.
So why are we actually bothering to render the 20 different agents who are training? Isn't that really expensive from a computation point of view? Not necessary.
Yeah, so it depends like where you're at. Like I think it's more like if you're still prototyping with these things, maybe parallelizing them will help you find more bugs that you would otherwise wouldn't detect. So let's say each of these tennis courts has some different randomly initialized parameters. You could have like different configurations, and then it's still helpful for you to visually inspect them. But you are right. Like once this is part of your workload and you're using this in production, and it's just a question of training it a lot, then there isn't really going to be anyone sitting and staring at this training all day. So
Yeah.
in which case, why are you spending compute resource like rendering it? But that said, it's not a it's not a this or that kind of thing. Like for example, like let's say I am rendering what's happening on my local GPU, but then I am training on a remote GPU. So there's no
Yeah.
contention in resources.
Sure.
Yes, I could still use my local GPU to train stuff, but also why would I? Like why wouldn't I just like look at it and then help know what's going on?
I'm really interested by the possibilities in not doing everything locally, using remote GPUs to train these things. Actually, if Unity is doing a collaboration with Google, I'll see if there's anyone in Google Cloud who's responsible for this, and see if you can set up a Q&A with them for your channel.
That would be incredible, actually. I would really
Yeah.
be because I think for me, Unity ML agents plus Google Cloud Simulation is to me at least the single most exciting project happening in software today. Like straight up,
Wow.
like I mean maybe Bitcoin is up there. I don't know. Like I have to think about it, but it's definitely up there.
For the streamers who don't know, Mark is a very big proponent of Bitcoin. We've had lots of debates on this, so we won't go into it here.
Yeah, not
But
other,
Pseudo agrees.
not shitcoins, not shitcoins, only Bitcoin.
Yeah.
Wait, just a second, Cap. I'm just gonna grab a cup of coffee. Be right back.
Sure. While you're doing that, actually, I might grab a beer.
All right. No, I don't know. Like, I mean, I definitely think Bitcoin is more interesting than GPT-3. Don't get me wrong. I think GPT-3 is amazing, but like, it's not like GPT-3 can like, I don't know, like single-handedly get rid of central banks and government-sponsored tyranny. Like, you know.
Pseudo says Bitcoin is the best thing ever after GPT-3.
No, I don't
I,
agree.
I,
I don't.
I think GPT-3 is way more awesome. I think the possibilities of GPT-3
I,
are incredible.
Actually, so
Uh,
I hope Sarah is still in chat because I want to show you one quick thing here. Something called the prefab. So basically, how are 3D models defined in Unity? And I know this isn't RL stuff, but so you'll see here, like we have this like tennis court object, right? It comes in here. It has this like fairly short net. And if we double click here on the prefabs,
Sorry, Mark, I'm going to interrupt. Do you mind showing again how it's done so I can do it live
oh yeah.
on my screen?
So if you go to tennis and then prefabs, and then it'll just be in the bottom bar here.
Where do I open tennis from? Is it in that folder?
Yeah. So if you go here, oh, actually, yeah, you're right because it doesn't show well in the stream. So it's here if you look at the right.
Yeah. So I'll go
and under assets.
And I'll just do this out loud if there are any noobs in the stream just like I am. So I'm going to go to my ML agents. Let me see. Where is it showing on your screen? Oh yeah, so it's an example.
Okay,
so
excellent.
Project, assets, ML agents, examples.
No, I am sharing screen with them from Hangouts. So like, here.
Okay, and then what file did you open in?
So it's assets, examples, tennis, prefabs.
Yeah, so I'm in tennis right now. Prefabs, and then in prefabs, what did you
tennis area, and it should be to the right.
Yeah, no, I see it.
So double click it.
Yeah.
So let's look at this for a second. So because like people like it's like often like I get into this debate with Sarah. It's like, oh well, how would I make art for your game? And so this is an answer to Sarah. At least for 3D, not for 2D. So you come in here, you'll notice like the tennis area, we have this thing called the tennis area. So that's like our top level object. And tennis area has a bunch of components. It has a ball. So this is a ball. You come to it here. It has a transform. It has a mesh. It has a collider because it's a physics object. It has a rigid body. And that's it. And then it has also a script called hit wall, which basically means that if you hit the wall, disappear, and give a score depending on the side that you want in. So if you want to implement a tennis game, this is how you would do it. Like as soon as the ball passes the court from one area to another, you're like, okay, one player got a point, generate a new ball. So this would be the full script for a ball, and you'll see this here. Like end episode, reset the match, and then net is equal to false. Agent wins, you set the reward, etc. So this is all like fairly straightforward stuff. If you look at Agent A, so here, for example, like we're saying, given that there's no person holding the racket, it's just the racket itself is a self-acting agent. It also has like a mesh, so the racket mesh. And so if I go to here, like you can actually see a 3D model for it. So this you would make in some other software like Blender. So I'm just going to open up Blender for anyone who's seen it. But 3D modeling is sort of its own thing. The reason why I really encourage it in general is because a lot of artists seem to be in this position where they're like struggling financially. But 3D modelers make as much money as engineers do because it's generally hard. And so while
I remember, was it with you in high school when we got in this Maya phase? I don't know if you...
I think
it was with Mark Farah.
Maybe it was with Mark Farah because like for me, like I often felt like I just didn't know where to get started before the internet happened. So
we spent loads of time on it. It was horrible working with Maya at the time. Like, it wasn't that it was difficult to use, it's that it was very tedious. And it would take so long just to make a really simple 3D model. So much respect to 3D animators, if any of you are watching.
It's really legit, honestly. And so like check this out. So you come in here, and all of this is like stuff like, let's say if Sarah's looking at this, like none of this is stuff that Sarah needs to do. Like I would come and program all this stuff, and what she would need to produce is like, let's say the smash, the tennis court, and then you'll see here, for example, like there's like the wall, so you'll see here, like for example, the wall is invisible. Why is it invisible? Because a lot of games are sort of hacky this way. It's basically we add an invisible wall, right? And if the ball hits this invisible wall, then you increment the score for one of the players.
Yeah.
But you don't need to see the wall. It's just there for like scorekeeping purposes.
I'm just going to interrupt the class a bit. A bit of troubleshooting. So when I click on the prefab file, it's just opening Unity Hub, and then it's still on the home screen. Do I have to open something first?
So prefab, you mean here, like where it says...
Here, I'll share my screen with you.
Okay.
Yeah, so right here, I'm in the prefabs folder right here.
Okay. Oh, no. Sorry, I meant do it from... Okay, yeah, sure.
Right, so
yeah,
I'm
so...
just going to open the worm thing.
Yeah, open it.
Yeah. Where was it again? Was it in scenes? Yeah, there we go. Oh, I'd be interested to see the dynamic target after this.
It's the exact same thing, but every time the worm hits the target, it moves randomly.
Right.
And okay, like you tell me how you would move it randomly. Like give me a high-level intuition.
I don't see how it would make it a difference, because on the fixed one, anyway, we're initiating like a random... Like even though the position is the same of the box every time, we've told the worm to start by aiming for a random spot, so it doesn't remember the position of the box. You remember when you were looking at the code?
Yeah, no, like that doesn't entirely work, just because. I mean, you just have to try it out, right? Like, I mean, if you try it out, you'll see that let's say you change the location of the worm. At the inference time, it doesn't. Like it'll just like move like towards the old target, and this is something I've tried out a lot. So it's just like you'll see it like if you ever work.
It'll still like kind of try to move towards the
old location. It's just memorized. Yeah.
But fair. Okay, I'm gonna stop sharing because this is gonna take time. So go ahead.
Okay. So we can just get back to this, but yeah, let me go back to Hangouts. Put your photo again. Whoa! Infinite recursion. Okay, so let's go here. But the high level idea here is that like when you're creating these meshes, this is very straightforward. Like in Unity, it's literally a rectangle. So you set up this rectangle and then you draw lines between it. But to show you, like, let's say the kind of stuff that people can do, let me show you. uh, crazy renders. So like just some inspiration, I guess. Like even though this is just like a shitty little square, this is not a picture. Like this is a computer generated render. So this is the kind of stuff you can make once you get good at this stuff.
That is wow. Can you go back to that? Oh no, it's just showing my screen when I'm speaking.
Yeah.
In the video.
Yeah, it straight up does photorealistic stuff. So for example, this would be like a kitchen. And this is this guy like Blender Guru does great tutorials on this.
That is crazy.
Here, like check this out. And so actually like part of what makes the skill set interesting is that if you learn a bit of 3D modeling, all of a sudden you can be an interior decorator. Because you can actually show stuff to your customer a lot better than being like, don't worry, madame, I will do it the best way you want, you know?
Yeah.
Like you can actually show it to people. And typically the most famous tutorial is that you start off making a donut. So this is the Blender UI, but this guy just does absolutely wild stuff with it.
On the point of interior decorating, a friend of ours, Karim Jaroudi, has an uncle who's kind of like this amateur VC.
Mm-hmm.
He invested in a company where you take loads of photos of a room, it turns it into a 3D model that you can walk around in VR. So like, you know, a realtor can show a property to someone without them actually visiting it, but they can still walk around through it in VR. And the startup flopped, but it was still a very good idea.
Exactly. No, like I totally agree. But again, like why I find this stuff very exciting is that it's sort of the same skill set that lets you do interior decoration, VR, games, animations. And so it's sort of like this very foundational thing. And programmers tend to not care that much about 3D modeling. And in fact, every time I've gotten into it, it's genuinely hard. Like, I mean, the most I've been able to do is shitty swords and stuff like that. But actually making stuff look photorealistic is amazing, I think. Like, and it's like, maybe like if I was a teenager again, I'd do it. Like, I mean, I still mess around with it, so I shouldn't say if I was a teenager again. But definitely it's something like I wish I did more of as a kid as opposed to paying attention in school.
Yeah. I guess you have to commit to it, like with something like 3D animation.
So Mazen is asking, can we use ML to make better anime? So I would rephrase that question. Can we use ML to make animations in anime a bit less painful? Yes. Should you watch a computer-generated anime? No. I think if you're watching a story that's entirely generated by computer, you should probably just do something else because it's probably not that good. All right. So let's go back here. Materials. Okay. So for example, like there's some other stuff here. Like let's say this is a demo file, like it's a video file. Because Unity also has, like, if you go to the asset store here, it's sort of insane. It's sort of like its own world of GitHub. And when you come in, you can, like, let's say, have a screen recorder app. You can have, like, a multiplayer app. You can have 3D models that people have built, a good 3D camera, a good controller for, like, 3D characters, a visual scripting language. So it's its own world in terms of ease of use. And it is, I think, entirely possible to make a game while barely writing any code. Oh my god, Berserk. Yeah, so Mazen is mentioning Berserk in anime. It is probably one of my favorite edgy animes. I just wish they would fucking update it. It is very slow, yeah, like for sure. I think reading it was a lot better for me.
Is this an actual store? Like, do people build 3D models that they sell for actual...
Yes, like people will end up selling them. And some people make a lot, like often you'll find that the people making tutorials will use it as a channel to promote their content on the asset store. But I don't think they make a particularly large amount of money. I think what the smartest people have done is figure out that they can use their YouTube channels as a way to promote the development and increase hype around the games that they're working on. So this is what's
I guarantee you someone has made a 3D model of their penis and successfully sold it.
Probably.
On the store.
There's like, you don't even have to guarantee it or imagine it. I've seen them. They're highly photorealistic renders. You can just go grab anyone that you like. All right, so I think what I want to do now is that we talked a lot about Unity, so let's kind of figure out how stuff works a bit under the hood. Like how does Unity actually make ML agents work? So the best way to do this is to actually just go to the GitHub repo in this case. So the first thing you'll notice is there's this thing called Gym Unity. And what Gym Unity is, it basically turns, here you'll see, actually wait, I'll be right back. One moment, guys.
While Mark's gone, I'm going to. So, little secret for the viewers: I still haven't been able to open the stupid tennis prefab. So while Mark's gone, I'm going to give that a try.
Yeah, sorry for the delay, everyone. Okay, so Mazen is asking, build a game that uses a deep learning model to generate a storyline for each action the player makes. So every player has their story based on their actions. We feed the model customized character models. The model learns to use them, and the model creates new characters when needed. Okay, I think that sounds like a great side project, but I don't think this will be a game that anyone will play. Just because, like, it's just generally hard to make interesting storylines with algorithms. It's difficult to have interesting computer generated stuff. There's like, I mean, some games get close.
So
like,
I disagree. I think take for example Heavy Rain, which was a huge hit. Like, sure, it's not ML, but it was basically the actions that you take in the game influence the story.
Oh, absolutely.
You could have something that learns from 1,000 or 10,000 different players' actions in the game to change the story. I think that would be more than a side project. That would be like I think even the top game developers struggle to build that.
So like here, like the only way I'll caution both of you is there's a sort of recurring meme in the game dev community. It's like you just go on the Unity subreddit and you're like, hey guys, like I'm learning how to program. Like I want to make like an MMO with dynamic storylines. Where do I get started? And it's kind of like, don't make an MMO for your first game. Do a shitty platformer, do a shitty puzzle game. You'll learn, finish it, you'll learn a lot, and then move on to more complicated stuff.
Right. If any of you haven't downloaded Unity yet, I just did yesterday. There's this very tear-jerking intro video in the beginning that's like 1:30 with all these famous game developers being like, I remember the first time I built a game in Unity. It was crap, and like a small tear rolls down their eye. But the message is clear. It's like, don't worry if your first game is shit. So I mean, I'm looking forward to building my game from scratch in Unity, not from tutorial, which will be.
Yeah, no, I think that's what you should do. I think that's the best way to learn, and it's something I'm excited about to have more sessions with you on. But let me just show you here. Like, let's get back to the RL stuff. Basically, coming in here, like, what does Unity ML agents do? At a high level, it turns. We don't need this. So at a high level, so Krishan, this is for you. Like at a high level, Unity ML agents will turn a Unity game into an OpenAI gym environment. And then once it's an OpenAI gym environment, you can run any reinforcement learning algorithm you want. And specifically, the algorithms they use are from a library, which is again from OpenAI, called Baselines, which has implementations for all the algorithms you could care about. So as far as you're concerned, you don't need to know shit about RL. Like you just come in and you say, I want to use, like, let's say, Kab, you asked earlier, why not deep Q learning? And so deep Q learning here shows up here. And it takes in, like here, for example, it takes in a learning rate, a total number of time steps, a buffer size.
There's a function called deepq.
Yes.
Oh fuck! So I was having fun learning Q learning like last month, and every time I build a Q online, I'd write like 50 or 100 lines of code.
I will say
Q values.
I will like going through the motions initially is very helpful. Like you'll still learn a lot. But like once you're trying to ship something, it's probably better to use other people's code.
Oh yeah, absolutely.
So I will also say, for those of you that don't know, OpenAI baselines, like the documentation, I believe is the single best reinforcement learning tutorial out on the internet. So just go there.
Can you tell the difference between baselines and Keras? Is Keras more like ML and baselines more reinforcement learning?
No, they're sort of solving related but different problems. So what Keras is a layer that sits on top of TensorFlow and PyTorch that simplifies machine learning model development. Specifically, the main innovation in Keras is that it has two functions called model add and model fit, where you can just add layers one after the other, and model.fit, where you literally just, let's say, like it's literally here. Like in Keras, you would say model.fit. Oh, fuck. It doesn't support PyTorch? I thought it did. Interesting. Always something you find out here. Signing off for now. Well, it's okay. It was nice having you, XMATFAD, and feel free to join anytime. So let me just show you this here. New file. Keras. So for example, like in Keras, you would say like model.add, and then you would say I want a dense layer, and then I want like a dropout. And then I want a softmax. So it literally turns writing machine learning models into this sort of model chaining API, which I think is sort of like once you see it, it's almost impossible to go back. Like you don't want it. You don't think of multiplying matrices. You think of adding layers one after the other. So that's what Keras does. And then it has this API called model.fit where you give it like your input and then and your labels, and it gives you a model. And then you do like, let's say, model dot predict on some new input. Sure. So it makes machine learning development super easy to use. Baselines, on the other hand, like what it does is it basically provides an API to really where it basically has these functions like deepq, ddqn, a3c. And then you would just basically call these functions as all their arguments. Is
it actually an API? Like, is it just a library, or is it an API where you're actually just sending your shit to be processed on an online server?
So right now it's just a library, but you could imagine there is a business need, I think, for turning it into a service where you have a service that sits. And actually, maybe that's a good idea for something I should like have built. But yes, like I mean, if you could just say like deploy it on cloud. And then it's good to go. Like, why the hell not? Yeah. Like it would work just great, and it would be something people actually used. So,
yeah. Well, I mean, you have Colab as something like that, but lots of people complain that Colab, even though you get presumably 24 gigabytes of GPU RAM, which is amazing, what you actually end up getting is a lot less than what you just would on your local PC.
It's not reliable. Is the main issue because like they'll randomly also stable baselines. Also, there's a shadow. Actually, it does it. Oh, and I really nice to see you in chat, Ian. So stable, I do want to mention stable baselines, like, and here's why. So when OpenAI baselines first came out, I think the main thing was that the documentation was really good. But then when it came to actually supporting more algorithms and having better docs and better callbacks for like integrating it with TensorBoard and having nice visualization, a model zoo, I think OpenAI baselines did an amazing job here. And they actually show you, like, I think it's one of those projects where was it here? They straight up had in their user guide, like their diff versus OpenAI. And I think that's a great thing all developers should do because they answered the question. It's a fork, like you'll see here on GitHub. It's legit a fork. But where was it here? So getting started. No. Vectorize. Exporting models. Where was it? Changelog? No. Project? No. Okay, I need to remember where this was, but I remember they had a nice stable. Maybe it's on GitHub. Yeah, so I think this guy Arifin is one of the like most underrated developers I know on GitHub. Yeah, there it is. So it's like, we have documentations. You can create custom yeah. IPython and notebook friendly. So this is an interesting one. So I want to just talk about this briefly. Like, so Cab, you talked about why don't people use Google Notebook for this stuff. So it turns out you can't actually render video in an IPython notebook. Or like you can't render like a game immediately from IPython. And so there's workarounds for this, and I think I was the one to propose it, even though I don't think it's a very popular workaround. But where was it here? It was a sort of a meme page. I think maybe that's why people didn't take it seriously. Let's say Mark Sarufi render Jupiter. I start way too many projects on GitHub to remember what the fuck I do. Where was it? Torch tree. Oh yeah. So I think this is like a good workaround. So basically, all right. So the main way I found, like, if you want to do more reinforcement learning stuff inside of a Jupyter notebook, and the nice thing about this stuff is that any Unity environment you can create, you can just turn it into an OpenAI gym environment and then just do this. Basically, the trick is, as opposed to trying to play it directly, you basically save the video of the game playing to an MP4, and then you open it within an iframe. Yeah, exactly. An iframe, and then you just do that. So this works just fine, and I haven't seen this trick be super popular, but it's probably like, if Mazen knows it, I would imagine probably also other people know. Not to discount Mazen, I think, yeah, that sounded kind of bad, but but I guess like my point here is that like it's sort of maybe like not really a secret, and it works just well.
Yeah.
Anyway. All right.
Cool.
So.
Okay, wait. Go back to the. I want to see why the I know the fuel bro comes up.
Oh, okay.
On the GitHub page.
Let's see. So this was. I think GitHub repos need more memes in general. Jupyter. Oh yeah. So I remember like, because like this is not as big a deal anymore. But back when I was doing this, especially on Windows, it's like you come in and you want to like, you download TensorFlow. Actually, sure, like let's do this then. So let's say you want to do some artificial intelligence stuff, and you went to your company's artificial intelligence and machine learning talks, and you hear people talk about optimizing processes and predicting house prices. You don't care about house prices. You can't even afford a house, or let alone rent for that matter. In fact, you don't even think about it. It just triggers your anxiety. But something in you feels incomplete, underexplored. You haven't feel like you've reached your full potential. You tell your spouse, friends, and family that you're going to go do artificial intelligence, and they nod at you. So you're feeling good. You're going to be an artificial intelligence expert. You're doing mental calculations of all the cash you'll be making, and you start telling all your friends that you couldn't believe how you didn't make this decision earlier. So then you do it. You download some reinforcement learning stuff, and then you import TensorFlow and OpenAI Gym, and you get this error in Windows. And so you cry. And maybe you're not like all that smart as much as you thought you are. And maybe some 8th grader just doing TensorFlow tutorials is way smarter than you ever will be and will make way more money than you ever will. So it's okay. And if that's what you feel, I would suggest like just open this up in a Google Collaboratory, and you can just import Gym. And if you want to record the training, you would just use my trick. I think I need to use this meme whenever I make something more usable. But yeah, like, let's see. So back to the actual session. I don't know how we ended up there. So yeah, so let's go back to Gym Unity here. So this was what I was talking about earlier. So as soon as you have any Unity game, you can wrap it within a Gym environment, and then you just treat it like any sort of other any other Gym environment. And that's why, like, I don't know why, like, people in reinforcement learning always seem to be obsessed about Atari games. And at this point, like, I think I could reasonably make the claim that if you throw a data center at it, odds are you will solve an Atari game. Like, good for you. But I would argue, like, a more interesting way to do reinforcement learning research is to come up with an environment that would test out a specific aspect of intelligence, like, let's say, diplomacy, lying, negotiation, and then see how well it does. And the nice thing about this is that you can just come in, and because you're already using baselines, or you could literally just import the stable baselines, what Ian was saying earlier, and you literally just feed it all of this. You save the model that you get into a pickled file, and then at inference, you just do this. And then when you're running this, you literally just go like Python-m, and then you train the environment. And that's it. Like
isn't that basically Yuri, Mark? You're taking a game in Unity, you're putting in a reinforcement learning wrapper around it, and then just running it.
Exactly. Like so I started working on Yuri before this became available. And so then when I was going over this,
Before it was cool.
Before it was cool, but then I realized like they sort of did a better job than me making it clear. And then I was like, okay, well, fine, I'll do the cloud training. And then
it's almost as if they had all the brains behind Unity and behind OpenAI thrown at it. Yeah.
As it turns out, I should have, like, I think in hindsight, like I thought a lot about this stuff, but I think instead of doing a platform and kind of get beaten by these companies that were like, just can throw infinite resources at this, I should have just made a game that has really good AI in it, and then tell people like, hey, you want AI that's as good as my game, just use my service. And I think the company that I've seen do this really well is these guys. So Noida. So Noida is a roguelike where basically what they do is that it's just like any old plain roguelike, but the main cool different thing about the game is that they have a fully simulated engine for sand physics, where every pixel is simulated. So you can see this. So what they did was they made the game. The game was very popular. It's very positive on Steam with a shit ton of reviews. But if you go to their webpage, they actually license their sand physics engine. Would you buy their sand physics engine if you didn't play the game? Probably not. And so the game ends up acting like the sort of incredible demo that makes you want to try their physics engine because you trust the developers. I think what was funny to me here is that, like, talking to friends that were doing startups, when I told them that this is how I was thinking about this stuff, they told me like, no, you're just wasting your time and just focus on the core product. In hindsight, I shouldn't have listened to anyone. I should have just done what I thought was best. Now, not that I'm blaming the people that gave me advice. Like they gave me the advice that they thought was best at the time. But at the same time, I know best what my core skills are. And I think making a game and finishing it would have been more interesting than trying to, beat Unity and OpenAI at their own game. I don't think that's very productive as a solo developer.
Yeah. Hindsight is always 20/20. I mean, I think that the idea behind the Unity project was really fantastic. And I think there might still be space for it, for example, to test board games. I learned recently that the board game industry spends a ton of time and money play testing their board games, and no one's really given them a good AI to do that.
I mean, yeah, like that's interesting. So, like, potentially, like, if like there have been people try to do board game AI in Excel, like there are Excel extensions that you can pay money for. But let's say someone reasonably makes their board game in Unity, then they could come in, use this with a bunch more wrappers, for example.
Yeah. Sure, but the thing is that board game developers, and bear in mind, board game
they don't do this.
Aren't just Ravensburger and the big ones. It's also like the people who make Cards Against Humanity or who make Secret Hitler.
Yeah,
whatever,
I agree.
Small games, they won't have Unity skills. So
100% agree. Yeah, so like you can see this. Like I want to maybe just quickly show this to you, Cab.
But I'm going to have to go in 5 minutes. For those watching, it's 8:30 p.m. in the UK, and I have to make dinner.
You don't cook dinner. Shut the fuck up. What a liar. You don't know how to cook. Why are you lying to the viewers?
The deal with my girlfriend is that I cook at least once a week.
Her food is incredible. I don't know about your food though.
Exactly.
Yeah.
It's a pretty good deal for me.
All right. So
I'm not complaining.
Okay, it's okay. I think we had like close to a 2-hour stream at this point. It was longer than we expected. But just so you know, Cab, like this is the Unity Cloud Simulation project. I think the main professional use case for it was like self-driving cars, because you can build really great simulators like this. So yeah, I mean, if you could get the person behind this project on stream, I would be super grateful. And we could just sort of talk about like the future of some of these features. Otherwise, Cab, like I'm really happy you enjoyed it. This is very close to Carla, Mazen. It's sort of similar, but why do it in a handmade engine if you could just use it in a more robust engine making toolkit? So guys, I hope you enjoyed this. Like this was different from the usual stream, like having a guest on and doing this sort of pair programming. I hope you enjoyed it. If you have any other questions to me or Cab in the next like minute or two, just feel free to ask him. Otherwise, I'll probably just rip on Cab.
Donate to formal system.
No, no,
It doesn't matter how
don't
much.
donate shit.
I'm just.
I have a job. I have a job. I just do
Or-
this for fun. I don't want to make money from streaming.
Donate to formal system. Donate your life savings. It's worth it. People pay big money for these courses.
So like Mazen, Sarah, Ian, like Krishnan, Xmad, like thank you all for attending. Cab, of course, like thank you so much for taking the time. This was great.
No, thank you, Mark. This is a really good tutorial. Anyone who's watching, definitely try it out. Go and download ML agents on Unity, open up the worm scene, and click into it. It's really, really cool.
All right, guys. Thank you so much. We'll talk soon.
That's it.